So, the meaning of density is a simple ratio in science. It's a ratio of a mass of a substance to its volume. It's a mass to volume ratio, which of course is very important because chemistry is a study of matter, and matter is anything that has mass and occupies a volume of space. So these two quantities are commonly measured and used throughout chemistry. So if we're simply asked what is a density of something, we need only determine what the mass is and what its volume is. So in this first part of the problem, where we're given a volume and given a mass, we can get a density very simply and easily by creating the very same mass to volume ratio that is represented by a density. And of course, if we have 87 pounds of mass in 4.5 cubic feet with two significant digits, our answer would come out to 19 pounds per cubic foot. Fairly simple stuff in terms of calculating the mass or the density from the mass and the volume. Of course, sometimes these units are not convenient, so maybe we're asked for a density in specific units, such as grams per cubic centimeter. And if that's the case, we can simply make a conversion. 19 pounds per cubic foot, 2 grams per cubic centimeter. Cubic feet, of course, can be converted to cubic centimeters by using a relationship with cubic inches. So I would say cubic foot is equivalent to a cubic inch in so much as one of these equals 12 cubed of these. And the feet cube would cancel, leaving us with cubic inches. Then, of course, we could convert cubic inches to cubic centimeters because the relationship is 1 cubic inch per 2.54 centimeters all cubed. And the inches cubed would cancel, leaving us cubic centimeters as units of volume now. And of course, we keep right on going because we want the pounds to be converted to grams. The connection between British and metric is through the pound and kilogram. So I would make that conversion right away. 2.20 pounds British equal 1 kilogram metric. The pounds would cancel and we have kilograms. One final step would be that 1 kilogram metric is equivalent to 1,000 grams. And those would cancel as well, leaving us with units of grams in the numerator and cubic centimeters in the denominator. We multiply this out and present the answer with two significant figures. We get 0.30 grams per cubic centimeter as a new density. So these two densities are identical. It's just that the units associated with the densities are different. And so, of course, the numerical value changes slightly as well. Now, we can use either of these densities to solve the third part of the problem, where we're asked to find the volume. And of course, even though it says how many cubic meters would be equivalent to 255 kilograms, by our 5-step number units label method of solving problems, we'd like to start with the answer. And the answer would be a specific quantity that we're asked for. Units can always be converted. Now, the quantity represented by cubic meters is a volume. And in my density, either one of them, I have a volume of this metal given. So I can use either one of these to get my answer. What volume of metal would we have? And for simplicity's sake, I'll use this one right here. The fact that 0.3 grams are equal to a cubic centimeter also means that 1 centimeter cubed of this wood is equal to 0.30 grams of this wood. And essentially, that's the quantity we're looking for. It may not be the specific units we want, but it is the quantity we want. So the remainder of the problem simply is canceling whatever quantity we don't want. And we do not want this quantity to remain down here in the denominator. And this is a mass of this wood. And we were given a mass of the wood in the problem and could cancel this mass of wood with this mass of wood if only the units were consistent. So my first step before I can cancel mass of wood is converting the grams to kilograms so that the units are consistent. And yes, 1 kilogram of anything equals 10 to the third grams. And the grams would cancel, and I've substituted kilograms for grams. Now I can use the given mass in the problem, 255 kilograms, to cancel the kilograms. And essentially we have our answer, because we wanted a volume of wood, and this is a volume of wood. But of course the last thing we always do in this method of problem solving is check to see whether the units are the requested units. And here we wanted cubic meters, not cubic centimeters. So we do have to do a conversion of units here and put the centimeters cubed down here and the meters cubed up here. And I know that 1 centi means 10 to the negative 2, but if we're cubing the units, we have to cube the values, and this would be 10 to the negative 6th. Centimeters cubed cancel, and now not only do we have the volume of wood we want, it's in the units we want. And then if we take our calculator and go ahead and divide 1 by 0.3 and multiply by 1,000 and then by 255 and then by 10 to the negative 6, we would get, with 2 digits, 0.85 meters cubed, which is a very reasonable answer. The wood is not terribly dense, but 255 kilograms, roughly 500 pounds, we need a fairly big chunk of this wood. And this is almost an entire cubic meter, or 1 meter by 1 meter by 1 meter worth of volume. So a very reasonable answer. In the last part of the problem, we said if a block of wood had a volume of 1 kilometer cubed, so we have this volume now of a kilometer cubed in this last part of the problem, we're asked what would be its mass. And we don't care about units. That's the last thing we worry about in step 5. We want to know what quantity we're being asked for. And we're being asked for a mass of this wood. And so once again, I could use either one of the masses in either one of these particular densities of the wood. But this would be a convenient one to use because we do want the mass to be in pounds. It will save us time converting later. So I'm going to start with the quantity I want. And the quantity I want is a mass of wood. There's a mass of wood over a volume of the wood. So of course I want to isolate the mass of wood by itself, which means I have to cancel a volume of wood. And the only thing that will let me cancel a volume of wood is a volume of wood. And this 1 cubic kilometer is a volume. However, there's a unit inconsistency. So I'm going to convert cubic feet to cubic kilometers. And yes, 1 foot cubed is equivalent to 12 cubed inches cubed. Feet cubed cancel. We now have inches cubed. And 1 inch cubed is equivalent to 2.54, all cubed, centimeters cubed. And inches cubed now cancel. And of course, to get from centimeters cubed to kilometers cubed, I'm going to take 2 steps. First, convert the centimeters cubed to meters cubed. And I know that 1 centi means 10 to the negative 2, but if I cube that value, I get 10 to the negative 6th. And then finally, I know that I can convert cubic meters to kilometers cubed. 1 kilo is 10 to the third of something, but if I cube 10 to the third, I get 10 to the 9th. Meters cubed cancel, and now we have kilometers cubed, which we can cancel with the given cubic kilometer, leaving us with nothing but a mass of this wood in pounds, and we wanted to know the mass in pounds. And if we multiply this out on the calculator, we get with 2 digits 6.7 times 10 to the 11th pounds of wood, which is huge. That's almost 1,000,000,000,000 pounds of wood. But in an entire cubic kilometer, there would be an awful lot of wood.